with her latest and greatest blank space. They will get harder. All right, let's get going with math now. Will you please open your packet to the page that talks about scatter plots and lines of best fit? It should be the one right after Lesson 11 homework. And I am recording this video without my iPad and stylus because it is not working, and I've tried to do it 5 different times now and it keeps freezing up on me. So hopefully this will work, but thanks for being flexible in advance. So we're going to talk a little bit about scatter plots and lines of best fit, which is kind of a breath of fresh air from the last couple of lessons. I know those have been tough. There's been lots of steps to follow, lots of things to remember, and so today's lesson hopefully will be a little bit lighter for your brain. So we're going to start out right on this page where there's a couple of fill-in-the-blank spots that you need to go ahead and fill in. A scatter plot is used to investigate the relationship between two variables. So it's a type of graph, it's a way of organizing and displaying data, and it's used to investigate whether or not there's a relationship between the input and the output. Another word that you need to know is correlation or trend, and it means how are the points in the scatter plot related to each other. So below there are 3 examples, and you can see that there's a bunch of points plotted on the far left over here. You can kind of see that they're not going in a straight line. You know, this isn't a linear fashion, but there is definitely a trend, and the trend is that it's going upward and to the right. And we call that a positive trend, just like we know a line that goes upward and to the right has a positive slope. So the correlation between these points, whatever it is that they're representing, is positive. Another way to think about it is as the independent variable or the x value is increasing, the dependent variable or the y value is also increasing, and that's happening consistently over time. In the middle here we have a negative correlation, and this just goes to show as your x values are increasing, what's happening to the y values? They're decreasing. And so we see that the trend is a negative, or it would look like there is a negative slope here. And if the points are sort of just random and they're all over the place, then we just say that there is no correlation. We can't say with confidence that one variable is affecting the other in a consistent way. Okay? If there is a trend in the data, we can use something that's called a line of best fit. It's also known as a trend line to represent the data. And so what we're sort of going to be doing is taking almost like the average or the meat and potatoes out of this data, and then we can make a straight line and use what we know about straight lines to write an equation, and therefore make predictions about what might happen to this data if we were to continue this trend. So for example, the data in this graph shows the resting heart rate and ages of 24 students in an aerobics class. Graph the 4 equations on the grid, choose the one that best represents the data. So I have done this for you already. I've taken a look at letter A, letter B, letter C, and letter D, the 4 equations that I'm given, and I went ahead and just plotted them using what I know about slope and y-intercepts. The first equation has a y-intercept of positive 80, which means it's going to cross the y-axis right here at positive 80, and a slope of negative 2/5. Now notice that this graph is not going by 1, a scale of 1. We're actually going by a scale starting here at 40 and then going by 5s. So when I go down 2 and to the right 5, what I'm really doing, if I go down 2 lines, that's really going down 10 and over 5, 10, 15, 20, 25. So you just have to be careful, watch the scale of your graphs. It still works out okay to go down 2 whole lines, but just know that I'm not going down 2 beats. I'm really going down 10 beats and over over, sorry, 1, 2, 3, 4, 5, over 25 years. Okay, so I plotted that first equation there and then just continued and drew a straight line. I did the same for letter B. We've got a y-intercept at 75. We've got a slope of negative 2/5 again, so down 2 over 5, drew the line. C has an equation of y equals 60, which I know is going to be a horizontal line here crossing at the y-axis at positive 60 and then just going straight across since the slope is 0. And then letter D, y-intercept of positive 75, and this one has a little bit steeper slope of negative 3/5. So I went down 1, 2, 3 and over 1, 2, 3, 4, 5 and then connected those points. Notice that none of the lines go directly through all of the data points, and so our job is to figure out which one does the best job of representing most of the data. So I want you to just think about if you had to choose A, B, C, or D, which one of these best represents the data. There's probably some that you know definitely don't do the best job at representing the data. For example, letter C, if I use this line to show a trend, this really isn't the trend of the data. And so right off the bat, I would probably eliminate letter C. Letters A and B look pretty similar, pretty close, although the graph for the equation from letter A is really only hitting these top couple of points. And so I'm going to eliminate that one too because I see that there's a lot of data points that fall underneath that line and I don't feel like this best represents that. So now we have it narrowed down between B and D. And D is sort of the other end of A, where again it's going through a lot of these lower points, but there's still quite a few above it. So I'm going to choose B because B to me looks like it goes sort of through the center of the data. Sure, there are some points above it, there are some points below it, but I would say that this does the best job of representing the trend over time and getting sort of that middle chunk of data to be included. So I would say letter B best represents the data because it goes through, it separates the points the best right in half. It's almost like it's drawing a line right in half of this lower end of the data and the upper end of the data. So now let's determine which equation best matches the data in the following graph. We've got two graphs here. What I notice about this first graph is that there's clearly a negative trend. All of the points are trending downward and to the right. And before I even look, I know you're given some equations here, but before I even look at those equations, I'm just going to do my best to sort of come up with an equation on my own using what I know about linear equations. So I see that the scale is going by ones, which is good. I notice that the y-intercept here is just below -1. I also notice that the slope, if I pick 2 points that are pretty easy to use because they're going through points or through an exact intersection, I might use this point. And then I notice that I'm going down 1 and over 2, and I hit another point on this line. So that has me thinking, okay, I think the slope is probably going to be -1 over 2, or -1/2. So I've got a y-intercept of somewhere around -1, and I've got a slope of -1/2. How could you use that, as well as the equations that are given down here, to figure out which one would best show this data? I'm going to have you pause the video, go ahead and finish numbers 1 and 2, and check back when you think you have the right answers. Okay, so here are the answers for numbers 1 and 2. Obviously, I counted a slope of -1/2, and that wasn't necessarily precise enough, but hopefully you could tell, once you've eliminated these two that have a positive slope, you could tell, hey, I'm not going down 5 and over 3. That would be a much steeper slope. So just using that knowledge about what we've been doing and what we've been practicing to help you sort of eliminate answers that seem unreasonable and then find the best one. Number 2 had a positive slope of 2, so right off the bat that eliminates C and D, and then figuring out whether it's a steep slope of 2 or a more shallow slope of 1/2. A was obviously the best bet. Go ahead and finish 3 through whatever the rest of them is. I can't remember if it's 3 through 6, and pause the video and come back when you have an answer. Here we go, 3 through 6. You can check your work. Hopefully you noticed for number 6 was some more work that needed to be done because all of the equations were given to you in standard form. So what I did, what I think is the easiest to do, is convert them right off the bat to slope-intercept form and then use what you know to figure out which one matches this line that's given. All right, so that is it for scatter plots and lines of best fit. We are going to talk about linear regression, which is what's on the next page. We're going to talk about that together as a class. And so for today, you are done. I will see you tomorrow. I hope that you have a great night. And again, if you have feedback, suggestions, or song requests, let me know. See you soon.